Iteshik is a scholar who has been studying engineering for space construction. He's a professor at Civil and Environmental Engineering Department at Hanyang University. He started his research on space construction in 2004 and has created man-made moon soil, concrete without water, and robots that can dig on the moon. The digging robot has already received its space license. An engineering professor turned space contractor. Let's hear his story. Hello and welcome to Heart. I'm Colleen Park. In the year 2006, NASA declared its plans to build a shelter on the moon by the year 2020. Well, do we even think that that's even possible? Well, a Korean professor certainly thinks so. Professor Lee Tae-sik from the Civil and Environmental Engineering Department of Hanyang University presented a plan to build roads and shelter on the moon. Please welcome Professor Lee Tae-sik. Welcome.
Nice meeting you.
Yes, nice to have you here. On the moon, is that possible?
Yeah, I think so. We are doing very good research right now to make the, first of all, lunar simulant we call, that is copy the lunar soil. And then we can make the lunar concrete then to build the road and to build the sheltering, and we can do that.
So what you're saying is you try to simulate what's on the moon here now so you can experiment and test?
Yeah, in 1969, the Apollo 11 to the Apollo 17, they brought 380 kilogram of a sample of the lunar soils. Right. And then we analyzed that lunar soil. We found the 32 different materials, and then we can copy it from the soil of Earth.
So we've been able to copy.
Yeah.
Oh, that's pretty fantastic.
That is very expensive. So about $16,000 per ton.
Wow.
And then we developed second materials that is just $6,000. Oh, actually $60,000 per ton.
Wow.
So NASA wants to develop about 0.1 million ton. So we can, make it the lunar simulant. And even though we don't have the materials in the Earth, so we need to develop the materials here.
I see. But so what you're doing is, are you trying to build like buildings and see how it works? Because it's different from concrete, like on Earth.
Yeah, but we don't call the house or a building because we call the sheltering or the habitat, because when you live on the moon, that means you are in the silo of the nuclear power plant. So with that environment, you cannot live without our sheltering.
Okay. And you can't take materials from Earth to build it because there's nothing there.
Too expensive. For example, 1 kilogram of the cement, that is $50,000, $100,000 the cost. So that is...
and you have to take it there.
Expensive. Yeah. It's more like gold or the diamond.
Okay.
So we should use on the moon. So we call the ISRU, in situ resource utilization.
Okay.
That means we can use it there, but we can copy of the soil here. And then we can test it, simulate, and then we can make it.
Wow, what an idea. Well, let's say you can build shelters or the habitats, but you have to get there. So don't we need a lot of shuttles or?
That is a good question. When Korean went to the Middle Asia in 1970, we don't have a Korean airline, but we used a different airline. Same thing, we can use different rockets, not by Korean.
Okay, so we would, like say, if back in the days when there was no Korean Air, you borrowed somebody else's airline, is what you're saying.
For example, the Canada did not care about the rocket. They only care about the space exploration, just like me.
Well, how is that possible? Because I've read that there are many countries or like firms that research just the space development, but not the process of getting there. That's somebody else's concern?
Actually, the President Bush and then President Myung-Bak Lee had a sign with the we called program ILN, International Lunar Network. That means we can use the American rocket or the European rocket, but we can collaborate together.
So you build the way to get there, and we'll build how to live there. So
Exactly.
collaboration.
Because
Okay. Well,
too expensive for the one country.
well, that's great. But let's say you had stated that there would be possibly habitats by the 2020. That's only 10 years away.
Yes, because actually every 2 years we have the field test on the Hawaii. Just Mauna Kea is about 4,000 meter high, and then we use the ashes from like the Iceland, the volcano has the ashes, and we can make the systems on the volcano, and then we can test it.
Right.
Actually, we can develop the water from the soil, and then we can divide oxygen. And then we use the methane gas, and then that is for the rocket itself.
Okay.
So we don't have to worry about the rocket, big rockets.
All right. Well, just curious, what would this habitat look like? I guess that's what a normal person would be most curious about. What would it look like?
Actually, they have 3 different ways. One is ready-made structures we call we call can. That means 4 meter diameter, so its height is 3 meters. That is just rocket size for the 4 people to stay. Okay. And the other one we call the expandable structure, just like capsule we develop, throw it away, that can make the big habitat. But still we need the covering by the lunar concrete. Otherwise you cannot live there because of the X-ray, gamma ray, and also solar wind, so people cannot live without that. But interestingly, already 2 hotels had a design on the moon. So Marriott and Hilton had designed for that too.
Oh, really? Oh, gosh, they're ahead of the game.
Yeah.
That's interesting. So we can reserve a room at the Hilton.
But with their design, they cannot build without my technology.
Right,
That is
right.
another problem.
But you're saying that just looking into the future, someone will build a habitat on the moon, and they're ready for it with their design, is what you're saying.
Yeah, exactly. And
Okay.
this year I was invited by NASA, so I went to the Hawaii, and then we developed, American developed, we call the sintering, as making the airport. But we suggest use the lunar concrete tile and just like the asphalt pavement, and they are considering very deeply right now.
And how does it help them by using this?
It's much cheaper and much faster, so we can help them and then we can collaborate together.
All right, that sounds good. Well, your field of expertise is engineering. How did you come to be involved in space technology?
Actually, engineering can be done, but my specialty is civil engineering. That means same thing. Only the difference is no atmosphere and the 16G, and other things is all same environment.
But gravity is like one of the biggest elements of how we live on Earth. That would seem like it would be like totally new calculations and totally new way of looking at materials and such things.
Especially if you play golf, you will hit very far and strongly.
Yeah.
So, but it's the same situation. I called it as an extreme environment. But not only the space, but also Earth. We have the same situation, South Pole and North Pole, and under the sea and the desert. And then people agree with me because it's the same situation with the civil engineering technology.
It's just more calculations this way or that way.
Yeah,
Extreme
a little bit
environment.
more expensive.
And more expensive. Yeah. Well, why are you so interested in space?
First of all, in 2002, I got the big award from the National Academy of Engineering. ISERI Park, the golfer, and also Yana Kim as figure skating best in the world. They had a slump after just that. Same thing, I got a big award between all the technologies. So I, consider what I can do, what I can next to step. So 10 years after, how can I the best in the world? And we have the two different ways, like Yona Kim, as they have a competition and then the best. But another lady, Oh Wan Sun, she got the 14 different mountains in the world.
Right.
And I'm same thing. I have two different ways. Do I need the competition, or do I have a special way to go? And then I decide that space engineering is one of the edge of the technologies. So I started.
It's still a frontier. No one has really conquered it yet. So that's you're doing something that not everyone is doing.
Yeah.
You want a challenge.
Yeah.
Well, what do your colleagues think of what you are doing? What are your aides, your research aides?
That's a good question. In 2004, every colleagues look me very suspiciously. Oh, Taishik Lee is now is a different way. He is not anymore the scholar. But I got many conferences with the experts, including the NASA and all the other space relatives. And also, we developed many technologies we call the element technologies. So making the copy of the lunar soil and then lunar concrete. Especially, I got the patent for the anchoring robot system on the moon and Mars. That is a big another step. So now they understand what I'm doing.
I'm very curious about the man-made moon soil and concrete without water and robots who can dig on the moon. So let's all take a look. Professor Lee Tae-sik's research center in Ansan. His office was decorated with various awards and accolades from civil engineering conferences in the States. He is currently researching for proper applications for lunar concrete.
지금 우리가 이걸 로켓가 내려오거나 할 때 공항을 우리가 만드는 거를 좀 콘크리트 패드로 만들려고 그러고요. 저 멀리 지구가 보이죠. 그래서 이런 것들을 다 한국이 만든 공항, 그다음에 도로 이런 것들을 다 우리가 만든 루나 콘크리트로 이제 포장을 하겠다고 나사에다 제안을 해놨어요.
What does man-made lunar soil and concrete look like? We decided to take a look and listen to the explanations from the expert himself.
이게 이제 우리가 경주에서 발견한 화산 현무암입니다. 그러니까 화산 안에 있는 현무암들을 우리가 골라서 이 중에서 우리가 채를 써갖고 이 내용들을 해서 각 부위별로 달 샘플이랑 어떤 게 가장 비슷한 거를 찾아내갖고 우리가 이 달 옵제트로 좀 옵제트 일부를 만든 겁니다. 일반적으로 사람들이 콘크리트라고 얘기하면 시멘트, 모래, 자갈, 물이 있는데 여기엔 시멘트, 모래, 자갈물이 없습니다. 이걸 루나 콘크리트라고 얘기하는데 좀 더 큰 사이즈를 만들어서 콘크리트 벽돌이 성공했고.
Because there's no water on the moon, lunar soil is made by melting plastic fiber as a substitute. Besides the man-made lunar soil, Professor Lee also invented a digging robot to dig on the moon. He received a special space license for the robots which will be used to buttress the buildings from weaker lunar gravity. Professor Lee's research aides are eagerly engaged with their work in their lab. Currently, the research team is working on developing the technology to aid material transportation on the moon.
지구에서는 무슨 비클의 차량 같은 걸로 운반을 해서 하는데 그렇게 되면은 달에는 더스트라고 해서 그게 많이 일어납니다. 그래서 그거를 최소한으로 할 수 있게끔 이렇게 파이프 시설을 해놓고 거기에 백큐um 시설을 해서 공기 압력만을 가지고 왜냐하면 루나 시뮬런트가 이게 가볍기 때문에 레골레스 가볍기 때문에 공기 압력만으로도 얼마든지 길게 이걸 운송이 가능합니다.
the sweat and toil in their efforts to materialize what is beyond our imagination. We eagerly look forward to the day when we can finally have a shelter on the moon.
앞으로 한 20년 후에는 분명히 달에 어떠한 구조물들이 건설하게 될 것인데 그 건설할 때 제가 한 연구들이 기여가 됐으면 좋겠고요.
제일 중요한 건 실제로 저희가 달에 올라가서 사는 게 거주라는 게 중요하기 때문에 그럼 그만큼의 이제 거대화를 시키는 거죠. 그게 앞으로 저희한테 남겨진 한 과제라고 생각하고 작은 거에서 좀 더 크게 만들 수 있는.
All very interesting. Concrete without water. Did you come up with the idea first, or was it by analyzing the soil, or what was the process?
Most important thing is the economy, how cheap you can make it. And so ISRU, In-situ Resource Utilization, is the most important. So whenever we are looking for the materials, we should find the materials on the moon or the Mars. So that's why it's very important. And then economically, it's a right selection.
Well, how many other countries are involved in all of this?
Actually, the Canada is heavily involving between the Canada Space Agency and the NASA. And European also interesting, Chinese also interesting, and Indian. But we had a big conference every 2 years. We called American Society of Civil Engineers and Ocean Space Conference. And this year, I went to there. I met Chinese professors from Tsinghua University. It's a very excellent university, but they are very low step. Even my graduate student told him, you change this, you change that, and so we are very good, within fifths in the world.
All right. Well, okay, this may be a very silly question. Why do we need to build a shelter on the moon? Why can't we just...
No, it's not a silly question. Very, very important question, because all the problem is from the energy. So finally, actually, Apollo 11 to the Apollo 17, and after Cold War, they don't want to develop anymore because too expensive. But now they found the very good materials, such as helium-3. That means 1,000 times stronger than by platinum. If we bring the 25 ton from the moon to the Earth, that can be covered 1 year for the America.
Of energy?
Yeah, energy.
Oh, okay. So a lot of people, when they say we're going to build a shelter, and you're talking about Hilton and these other hotels who've already designed, people are thinking, oh, okay, I'm going to live on the moon. It's not living on the moon. We're going to mine moon so that we can bring something back from the moon to help us and our lives on Earth.
We have two different occasions, but most important thing is energy stuff.
Okay.
Helium-3 is, we can save all the Earth. And second thing, have you seen the movie The Core?
Yes, yes.
They have the problem for the ion layer. That means we need to find the new place where we can live. That is another option too. Like Columbus, actually for the industry, but also living in America.
Right.
That's the same things.
Well, then let's say that the world gets together, many different countries come together to say, go do the shelter, the habitat, and bring back helium-3. How is it divided among the countries? How is it used for the good of the Earth all around and not only for a few countries?
Oh, that's a good question. For example, we have the International Space Station. We have different modules from different countries. And then we are collaborating together. Same thing, if we do have more helium, then not only helping the America or Korea, but also all the other countries, the same situation. Maybe we need like system like United Nations. Maybe we can share each other.
United Lunar something.
United Space.
United Space. Well, that's sort of what Yeah, okay, that's good. That's another story.
Yeah.
All right. Well, it would also, with all the things that are happening in Korea and the world with lunar development, but there must be a growing interest in students and space development in Korea too, because of we did the first satellite launch, was it? Yeah. So how is, I heard that Hanyang University is opening a summer space school. Tell us about that.
When I met the NASA or the Canada Space Agency people, when I talk about my technologies, they say, oh, it's good. But when I say that space study program from the International Space University, they open their eyes, oh, you are really? Because that space study program is like the Olympic game. We make the proposals and then to give it to them, and they decide which country they want to have that program. Frankly, our proposal is excellent. So even they decide only the 2011, but they decide this proposal is too good. So they decide we can hold that space study program in 2012.
So what kinds of things will happen within the summer space school?
Oh, they have a very good, for example, the knowledge base, and also they have some experiments, like the robo is automobile in the moon and Mars. We call the robo. They have a robo competition, and they have many themes about that. And this time, we suggest we make the lunar engineering and construction for habitat. They are trying to make the lunar simulator by themselves, and then they will be ambassador of Korean technology.
All right. Well,
future.
With your teachings and the background of being civil and environmental engineering, that's really great. So the preparations are going well for it, and what does Korea want to achieve with space development? I know we covered it, but you personally, what else?
We have many suggestions. For example, we make the lunar concrete. That is not concrete on the Earth. No cement, no aggregate, no sand, no water. But that is all the materials from rocks. And then we can make it only 30 to 40 minutes to, concrete.
Oh, to make it hard.
But the Earth concrete is at least 28 days to make it. So maybe we can make it new materials for the buildings, or even though if we can develop for the moon and Mars, we can use the materials on the South Pole, under the water, because the same situation. The South Pole has temperature is minus 150 degrees to the 100 degrees per day on the moon and Mars. That means we can make the very extreme environments on the Earth too. So these materials can be used not only space but also on the Earth. And also we found there is good material for the health too, because the Earth concrete is not good for the health.
Right.
So, first building, there are many symptoms to not to be good, but this one can be good.
All right.
Very eco-free.
You want to develop and capture moon so that it would help Earth.
Yes.
That's what it seems like. Yeah. Well, that's very, very interesting. The best of luck with everything and the 2012 Summer Space School. Thank you for being with us today.
Thank you so much.
Very informative.
Thank you.
Well, you can rewatch and learn more about lunar habitats and what's happening in space through watching our Arirang website. Thank you very much, and we'll see you next time. Bye-bye.